that going. Cool, so tonight's topic is procedural content and really what it is, what it's about, and some kind of how it works and tips and tricks and things like that. One thing that Alan actually just sent me a little bit before this is itch.io is sponsoring running a procedural content generation jam starting in 21 hours. It's kind of weirdly like good timing. So really, what is procedural content? That's kind of where we'll start. And I think a good place to start with that is to talk about something called RNG. And so if anybody has ever watched any like speed runs of video games, like if you watch AGDQ or any of those things, you'll hear people who are trying to make it through a video game really fast say they got screwed by the RNG, or the RNG was favorable to them on this run. And that means random number generator, and that's been a thing in games really about as long as games have been around. You have to have some way of making the experience have some variety. And so very early on, people incorporated random number generation into games. But there's something really important about that I want to start with, and that is computers cannot make random numbers. They can't do it. And like if you think about that, like if we want something random, in real life, we'll flip a coin, we'll roll dice. That's depending on the existence of something that's called entropy in computer science. And a word I like to use is just chaos. Like when you roll dice, there's gravity and there's air moving through the room, and there's all these different things like that. The angle that the dice come out of your hand is just slightly different every time. And so you have chaos, and chaos is going to give you a different number on those dice that is unpredictable. And theoretically, if you knew every variable that went into that dice roll, you could predict what it's going to be, but there's so many that our minds and our current technology is incapable of that. With computers, when you have stuff like a dice roll or a coin flip, it's simulated. You don't have all that chaos. And so really on a computer, if you rolled a dice and you started with the dice in the same position every time, you would get exactly the same result because the physics simulation is deterministic. There's no chaos, there's no randomness in that. And so really computers are incapable of generating a random number. So it's kind of like, well, that doesn't make sense because computers have to generate random numbers all the time, and that's true. But for them to do that, they have to rely on something called entropy. So there has to be some input coming from outside of the code itself to give it some seed of randomness. So I put together a super simple demonstration of that. That's code. So this is just a really simple console application, only a couple of lines. I'm not going to get super deep into the code side of things, but basically what this is doing is creating two different instances of a random number generator, and then I'm going to generate two columns of numbers, one from each of these generators, with 10 numbers in each column. And if you're an experienced programmer, you'll know that potentially we could end up with the same numbers, but we're not going to go into that exactly. So here's two lists of 10 numbers. The lists in each column are different. So clearly my computer is capable of generating some random numbers. It's doing that right now. You can see in the code, I'm creating a new random number generator, and I'm calling rand.next, so I'm getting the next number from this generator. So how is that working? Well, these, when you call new random in every computer language, behind the scenes it's starting with something called a seed. So the computer can't come up with random numbers. And so it starts with a source of chaos, a source of entropy to seed that random number. So typically in the past what that's been is like the current time in milliseconds. That's something that's constantly changing. So if you get the current time in milliseconds and you use that and then you run a hash or some kind of calculation on that random input, you're going to get a set of numbers that's going to be different from what it was a millisecond ago or a millisecond before that. So that gives a computer a way to create a random number. Go ahead, you.
Quick comment, if it's all right. As far as encryption goes, we have the same requirements to use random numbers for that. And I know of a hack they did once where they forced a server reboot, and then because the encryption was based off of the seed of the encryption, a random number for the encryption was determined you could determine what it was because the server rebooted. So you could use that time on the clock and figure out what the key
Right,
was
like
for, was gonna be on
Yep.
the, and that's.
Yeah,
what
so I'm
they
actually
had.
gonna demonstrate exactly that.
number of seconds since the last reboot or
Exactly.
something like that.
Yeah.
Yep. So we're gonna do that right now. So you can start up this random generator with specific input called a seed. And so I'm gonna give these both a seed. Just gonna do 1, 2, 3. And when I start this again, you'll notice something interesting. Now, the numbers in each of these columns match. We're getting exactly the same numbers. So this proves it's not actually random at all. All it's doing is running an algorithm or a hash or a calculation on the input and giving you a set of numbers based on that. And so that's really interesting for exactly the reason that you said. That really sucks for cryptography because if you are generating like a slot machine or you want to generate a random password that is not guessable, you have to have enough entropy coming in or chaos coming in to generate a set of numbers that it's impossible to guess. So like Alan was saying, if you're just using the system clock, well then if you can predict that at a certain time, then you know when the next jackpot is going to be. And there have been tons of hacks that have exploited that for cracking passwords or exploiting casino games, anything where depending on a random number has some, breaking that has some kind of incentive. So that sucks for cryptography. We're not going to go too much into that because that's a little bit of a rabbit hole, but it's actually awesome for game dev. And the reason it's awesome for game dev is if I know that I can get a, for practical purposes, infinite set of numbers given a very small input, and those are going to be the same every time, I can use that to predictably generate worlds, which is what games have started to do. And so procedural content kind of starts with random numbers, and games have for a very long time used random numbers to determine behavior in games. So if the number is a 1, the boss goes this way. If the number is 2, the boss instead shoots his primary cannon or whatever it is. But it hasn't been a ton of time that games could actually generate content from random numbers. And that's really because processors and memory and that sort of thing had to get to a certain point where we could do that fast stuff. So really, there's a lot of kind of arguments and discussions about the difference between random generation versus procedural generation. It really doesn't matter. There is no true random generation in games because if you just ask for random, what you get is noise, and that's not useful. That's not fun. And so everything has a procedure to it that is combining the ability to get random information and then mix that with human guided rules to create content that is interesting but is partially generated by a computer. So that's kind of where it started. A lot of games, so anybody who's ever played Minecraft uses a seed. And if, I don't know if they still do this, but you used to be able to specify the seed. That game's evolved so much.
You still can?
Yeah.
Can you? So yeah, so you can share your seed. If you generate a really cool world that has like a really cool starting place or whatever, you can give your friend that seed, they can punch that in, and they're gonna get exactly the same world, which is crazy because Minecraft's like, for all practical purposes, infinite, but you can start with like a 10-digit number and get exactly the same world. So we're gonna talk, go ahead.
So when you first generate a new Minecraft map, what it's probably doing is generating a seed pseudo-randomly based on the clock time in milliseconds.
Yep.
And then
Or
using that
taking
seed to generate
user-
everything else.
Yeah, and so here's what's really interesting about that, and I don't want to go too into this because I'm trying to keep this to an hour and I have a lot of stuff to go over. So games like Minecraft, what they do is they generate the initial world from a seed, and then they only save the changes to that the player has made. The problem that causes is if your world generation algorithm changes at all, so let's say in the first version of Minecraft they only had a forest biome, and then they add desert. Well, now you can never regenerate the same world because you're using the numbers from that seed in a different order. First, you only had like you were only checking the random number one time or something. Now you're checking it a couple times, you get different numbers, and that's a little bit hard to explain. Go ahead.
A little bit more of like a practical, like showing that they've actually taken like old worlds and brought them into the new generator.
No,
And
totally screwed up.
What it'll do is because it generates based on a 16 by 16 area,
64, yeah.
And so what it'll do is it'll just generate 16 by 16 chunks randomly. So you'll have like a forest and a mountain right next to it, and they don't move into each other, nothing.
Yeah,
They have no.
because one of them has been explored and then saved, and then but the other one hasn't. So yeah, when it goes to generate, it's using a different algorithm.
Yeah.
So it's like, yeah, there's like a snowstorm here and then a desert mountain right next to it with a solid wall. Yeah, so you can kind of run into problems because the seed will generate the same world every time, but as soon as like the player starts interacting with that, they've made changes now. And if your world generation process changes at all, then that seed is going to generate totally different output. But as long as the process is the same and the seed is the same, you will get the same results every time with a computer, which is cool for game dev. So kind of the next iteration where random really expanded into more interesting usage came from a guy whose name was Ken Perlin. And I don't know if anybody's seen the really old 1982 Disney movie called Tron, but Ken Perlin was working on Tron, and it irritated him that computer-generated textures always had this kind of look. They didn't have an organic feel to them. And Ken Perlin was clearly much better at math than me because he sat down and figured out a system for generating organic looking textures, and that system's called Perlin Noise. And for the math people, the way that it works is you generate basically a grid, and on the points of that grid you generate a random number and a vector. And then you interpolate between the points based on the random number and the vector, and you convert that into colors, and now you have a random texture. And we're going to show you guys, because that explanation sheds no light on what it actually means. But if you are mathematically inclined, the wiki article on Perlin Noise is great. It has a pretty clear explanation even for non-mathematical people. But that was one of the big things that people considered a starting point, was Perlin Noise. And now there's been multiple variations of that. There's fractal noise, there's simplex noise, there's difference noise. There's all these different kinds of ways that people have evolved that. And then it's also been optimized in different ways so that it can be faster. Like simplex noise generates faster on a graphics card, I believe. But Perlin Noise was kind of the start of it. And interestingly, he wrote an article on that, I think it was in 1985, and submitted it to SIGGRAPH, but he never got a patent on that. So Perlin Noise has never been patented. It's used everywhere. It's just something that is a great utility, but it does retain his name. So let's jump over to Photoshop and demonstrate what Perlin Noise kind of looks like. And honestly, I don't know, I'm sure that Photoshop is not using true Perlin Noise. They're probably using some advanced version of that. This is going to give you an idea of what Perlin Noise does. So I'm going to go Filter, Render, Clouds, and this is essentially Perlin Noise. So if you put this as a texture, it's a lot more organic than anything was feeling in like the early 80s. Now you can do a lot more with this. You can layer, fractal noise and things like that to get specific looks. So you can fully generate textures that look like rocks or grass. That's actually not used that much at runtime. We'll get into why a little bit. But let me show you a couple of the things that you can do with Perlin Noise. So looking at this is like, okay, we have some sort of clouds, but how is this actually useful? Well, if you're imagining Minecraft, and let's say you've generated a flat chunk of land, and now you want to create some lakes on that land. But if you try to do the math to create a lake, will it either be really deterministic, like you start with 2 squares wide, and then it goes to 3 squares wide, and then it goes to 4 squares wide. You'd either have to have a ton of weird random calculations and if statements and kind of control blocks, or you'd have to come up with something different. And Perlin Noise is the difference. So if we take this cloud that I generated and we start compressing these levels, now we have bodies of water and land masses. So now I can take and overlay this pixel by pixel onto a voxel grid and say everything that's black needs to be water, and everything that's white needs to be land. Or you could do that with deserts, or white is snow. You could also do this underground, so everything that's black is a tunnel. You can change how these are compressed down. So now, those are resource deposits, and everything else is bare land. So noise is super important in games because it makes it easy to overlay different features that look organic without having to write a huge amount of flow control and random checks individually to kind of figure out how that's working. And so this is how most games are doing texture generation and landmass placement and things like that. It's a combination of noise, compression of that noise, and then overlaying that with some rules that make it more interesting. So I mentioned, you could use this for texture generation, for clouds, for ground, for things like that. Let me show you something else that you can do that's really cool. You can take this and basically every pixel in this, if it's grayscale, is going to be between 0 and 255 in value. That's the range of RGB color values, 0 to 255. So you can take that and build a height map out of it, it's called. So you can take a grid and create that and determine the height of that grid based on the color value or the blackness or whiteness of that pixel. And now you have a height map. And what's cool is Photoshop, and this is part of the reason we're simulating this can simulate this for me very quickly without having to bring a game engine and everything into play. Ooh.
The curse of the demo.
Yeah. Let's try this one more time. I kind of suspect in order to record this, I had to force it to use my integrated graphics, and it might not like that. Let me just try something real quick.
This is when you start heckling the teacher.
This is when the photos dry out.
Let's see if we can. I can't remember where the settings are that allow it to use the
3D.
No, it wasn't actually 3D. I looked in there. Let me try turning this off so it's not using the graphics processor, and we'll just try this again. Oh, then I can't do anything 3D. We'll come back to that. I might be able to get that to work. But basically in Photoshop, if you have Photoshop, you can do new mesh from layer, and it will create a height map for you. Most game engines can also create height maps given a grayscale height map input. So if you work with like Unity, you can import a grayscale image like this. You could draw on it, so you could draw like little roads and things like that at specific colors. And either the darkest colors will be the lowest points, or they'll be the highest points. You can kind of set it up either way.
So is that how terrains and a lot of things like that are built?
That's how they start. They'll start with a height map, and then they'll sculpt it. Or you can actually do the reverse. You can create a 3D plane. You can create sculpting tools, spend a lot of time sculpting it and making it really nice, and then save that out as a pretty tiny grayscale image. What that doesn't work with is things like caves that go in, so you'd have to store that information somewhere else.
Yeah.
But if you don't have any convex or, I think it's convex, terrain, then a height map can save that in a very compressed format. So that's another thing that you can do. So
the
let's
default Unity terrain works. It's just like that. It's an height map image.
Yep. Yeah, and you can edit that in Photoshop. I have in Unity. I've made like weird mountains and tried drawing paths in Photoshop and then brought it into Unity to see what it did. And then again, you can do the inverse. You can kind of generate terrain, sculpt it, create, like paths up a mountain or whatever, and then you can bring it into a grayscale image and see what it looks like. And there's a lot of YouTube demos of that kind of stuff. So this kind of failed, but you guys can find that pretty easily. So, all right, let's make some actual procedural content. So we're going to use a combination of humans and Photoshop acting as our game engine. And we are going to make a planet. So I'm going to go around the room and have people pick a number from 0 to 255. So go ahead, give me a number, any number.
207.
207. All right, go ahead. What do we got?
111.
111. All right,
92.
92. All right, we got ourselves a reddish color. I'm going to do another color. Go ahead.
76.
76. Brady?
57.
57.
69.
69.
Of course.
All right. So we're going to create a new layer here. Photoshop can generate colored noise, which is basically the same thing. It's just instead of black and white, you're using some colors. We're going to make this a little bit more interesting by doing difference clouds on top of that, and we're going to do that a couple times until we get some kind of interesting textures going on here. All right, so now we have a texture. This could be a terrain texture, a planet texture. We're going to turn this into a planet. So the next thing I'm going to do, and I'm not really doing art here. All I'm doing is executing a series of mathematical routines in a way that's a little bit more interesting to watch than watching me write code. Plus, I don't think I'm smart enough to write the code to do things like spherizing this. So we're going to spherize this. All that did was bend it and make it look like it's on a 3D model. I'm going to turn on this grid just so I can get a precise selection here. We're going to delete the stuff that's not one of those because we don't care about that.
Look at that.
We're going to actually turn that grid back on, resize this down a little bit like this, turn the grid off. Now we have sort of a planet, but it's really missing some dimensions, so we're going to overlay some shadows on it. So now it's round, like clearly round, and we're going to give it some atmosphere. So just like that, we have a planet. I did no art right there. That is 100% procedural content generation. I defined some rules, so we defined some colors, but really I didn't even define any rules there. And then we just applied some math to noise, and we got a planet. And this is actually exactly how my game generates procedural content. But to really do this, either you have to replicate all of this cool stuff that Photoshop has built in, so I'd have to know how to create that rounded texture look. I would have to know how to create this nice glow effect. I would have to know how to create that noise. And you can do this, so I could do all of that, but running all of this would probably take 10 to 15 seconds per planet, which is probably an unacceptable amount of time. It might be faster than that, but even if it was 2 seconds, that's a lot of loading screen time to generate textures. The other problem that you have is you have to store that information somewhere after you generate it. Even if you generate it on the fly, you still have to store it somewhere to pass it to the graphics card to actually render. And that's kind of where you get into a problem because artists very carefully optimize textures into texture maps where they're stuffing multiple textures into one file. So the graphics card doesn't have to constantly switch textures. When it's rendering, it can pull textures from 6 different places in the same file. And I did demonstrate that, I think, a while ago. So that's procedural content causes a couple of problems when you go pure procedural content. If we wanted to do all this in game, we would likely run into some significant performance problems, or we would spend a lot of time optimizing this process. So how do we make this, how do we take some of these concepts and make it to where I can do this in the game, but without it taking a ton of time and without me having to rewrite a lot of Photoshop's code to do cool stuff? Well, Photoshop has something called actions, and this, my workspace changed here, let me change back. And so I've actually, the individual steps I did to make this, I recorded as separate effects, so I can actually generate planet texture. So that, just to back up a little bit, that planet texture, assuming I already know how to do it, which I did, like creating that one planet might take me 10 or 15 seconds. That planet wasn't that cool. It was pretty cool because we just saw it happen and maybe we haven't seen something like that. But like if all of them look like that with just different colors, that wouldn't be very interesting. And so to really get interesting planets, it takes a combination of the math but also like a human eye for what makes an interesting planet. Because games aren't trying to be real. Most planets in space are pretty freaking boring. Games are trying to be, interesting and cool. And so pure math doesn't necessarily give you cool. You've got to mix it with art. But if I sat here and created 400 planets, that would be enormously time consuming. So what I did was I wrote or recorded actions, which are basically like macros. And this allows me to simulate what the game might do given 40 times to try to create. These can be a little bit finicky, but let's try to run one. So this is redoing what I just did. And I got a texture. Let me make this white, and it's going to be a little bit more interesting. So let me delete that texture. Now I've saved this as an action. So that one's kind of cool. Make another one. That's kind of cool. Now this particular type of texture I'm generating is kind of like, it could be clouds, it could be lava. It's transparent, so I can overlay it on the other texture, assuming they were the same size. Okay, and then I could start colorizing this. So already like that having clouds makes it a little bit more interesting. I could start colorizing this and say, you know what, this has really pink clouds. Well, now that planet already looks different. That looks different. So being able to create multiple textures and layer them adds another dimension and more interesting combinations. We can also generate different types of textures. So I have one called Planet Landmass. This is a little bit different process of generating noise that is attempting to simulate something like continents. So let's make a couple of these. And the important thing here is I can iterate fast. This isn't interesting. If I had to create that by hand and I went through all the steps to create it and spent 5 minutes on that, and I was like, well, that's not interesting and I need to do this 400 more times, that's a lot of art time burned. So to me, this is still procedural content. Even if I save this texture and it's not generated on the graphics card, I'm using tools to help me create this content rather than drawing everything by hand. So I can sit here and I can just generate this 100 times. I could do these and I could pick my 6 favorites. And that's actually exactly what I did. So I created multiple different versions of Photoshop actions. I generated like 50 different kinds of planet textures, and then I looked at them and was like, ooh, that one's kind of cool. I kind of like that one. Well, maybe that one's kind of boring. And so I sped up my art process a ton by generating a lot of these. I also did that for suns. This, due to some kind of constraints to how this works, I actually have to resize the canvas at 1024. My sun textures are larger in my game, and I built the actions for a larger canvas. But check this out. Let's give myself a black background just because it's a little bit more interesting to look at. Not used to working on such a small screen here.
Look up.
Well, that screen's bigger, but I mean, I still have the same real estate. I'm used to having like 5 monitors to work with. Okay, so now I also did the same thing for sun textures. And it would help if I didn't generate it in black. Because black on black is not super interesting. So now I did the same thing, slightly different system, but here's a sun texture. So really kind of the same process, but I have this burst effect, and I can colorize these. So I give this a color, okay, and I can generate another one. Okay, and I give that a little bit different color. Like this. Pretty soon I have a pretty freaking cool sun. And then the cool thing is I can mix that. So I can have 4 or 5 textures in white that I have sort of hand curated from Photoshop's capabilities, and then I can colorize them in the game. And if I have 5 or 6 white textures that I'm layering uniquely and rotating and colorizing in the game, I suddenly have a huge amount of variety with my suns and planets and everything that are generating content for me, and I've sort of still been able to apply an artist's eye to it to make sure that they actually are interesting. So I'll show you guys some more with that, but a lot of procedural content is using a combination of pre-baked stuff, is the phrase I use, so stuff you've generated maybe procedurally, but then saved down to texture data, and did not generate on the fly. There's a lot of problems with generating textures specifically on the fly to do with how graphics cards work and how things are optimized at render time. So let's talk a little bit about then types of procedural content. So procedural content is content that's been generated through a combination of art and math. And you've seen a little bit, I tried to make this kind of visual so you could see really what's happening. Photoshop is just acting as a game engine here. So all that's behind this is doing this is code. Like I haven't actually gotten a brush and drawn a single thing throughout this whole demo. I did not hand paint a single pixel on screen. I think we just lost our output. That's fantastic. All right, not sure what happened there, but. So let's talk about a little bit how this stuff has kind of evolved and how games are actually using this. So some examples of really early random content, and I'm going to kind of just bucket random anything into one bucket. I don't really care about like what the distinction is between random and procedural, because to me, everything procedural is the scale of math to art, and it falls somewhere on that scale, and different games do it to a different levels that are really interesting. So going all the way back to Super Mario Brothers for Nintendo Entertainment System, actually again, Alan shared a video earlier this week in a chat that we had that was talking about hacks that speedrunners use to get through Super Mario Brothers. And if you watch that, the speedrunner who currently has the world record waited on the title screen for a specific amount of time. And the reason he did that was because he set the seed for the random number generator. And that didn't apply for him much until he got all the way to the last few seconds of the game when he's fighting Bowser. There's a specific pattern that he wanted Bowser to have that allows him to pass through the last hammer that Bowser throws. And it's insane that like at the very beginning of this run, he waited a precise number of seconds.
That's how you get a world record speed run.
Yes,
like that.
yeah.
This is
And so he
world-class.
actually was manipulating the random seed, and that was at the end of the game choosing the pattern that he wanted for Bowser. And so even back in Super Mario Brothers, they were using a random generator. It was very primitive what it could do on the Nintendo Entertainment System, but that was used for boss behavior, specifically Bowser. It's used in a few other places, but I don't think the other places were as exploitable, so I don't know. But it was used consistently enough that the timing on the title menu affected the very last level in the game, which I just think is pretty cool.
Wow.
And how people figured that out is also pretty cool. So movement and spawning is one way that you can use
Do you
random.
think he just knew that that's how it was generated, or did he like wait and do another millisecond, another millisecond? Oh, that's not
I
right. That's
think
not right.
people read source code and knew,
Yeah.
and I think they knew that the patterns were like one out of a set
Six.
number.
Mhm.
It wasn't just this guy, like it's a whole community of speedrunners
Yeah.
all, and they're like all these
Brute
guys.
forcing the game, trying to
Yeah.
figure
I think
everything
that guy
out.
said he estimated he'd run through Super Mario Brothers like 4,000 times trying to set, and he just set a near unbeatable world record. Like it's crazy. But so that's the most basic example is movement and spawning. And games have used random number generators for movement and spawning probably since pretty much the first game. The next thing that you can use it for is the actual generation of the game entities. And so a good example of that is if anybody has played Borderlands, the guns in Borderlands are a combination of components that are assembled. Yeah, and that's gonna come up in just a little bit because one of the bad things about procedural content is it can be game breaking. You
You could get that perfect gun that happens to shoot once every second.
Yeah, you
and
can't
it's like,
know
it's not practical
how-
to use it that
like
way.
if we had been using random colors in this, there is a chance that every color we randomly picked was white, or every color was black. And in either of those cases, our sun wouldn't be very cool. So, you have to put some constraints on it, but if you constrain it too much, you lose the randomness, and it's kind of hard to guess what can happen. Go
Yeah,
ahead.
sometime.
And when you go into the random side of things, I don't know if any of you guys played Monster Hunter, but in not the last game, not the last big one, but the one before it for the 3DS, they had you could get random drops from basically the final monster that you could hunt, and they would randomly generate when you identified them, and it was literally random. So sometimes you would get like a greatsword from it, and you would get like the last tier physical greatsword from it, and it would have the end game fire damage on it. And sometimes you would get the end tier greatsword, but it would have like a physical damage of like one of the basic ones.
Oh, so
And
they
it
put
was
enough
Total
constraints.
junk.
Yeah, but the problem was that like they had upper limits to things, but there were so many options that it just was completely impractical to even try and do it.
Well, there's other things that you have to think about too in your game design. So another example is the game Divinity Original Sin, which is like an RPG, kind of isometric RPG game. You can move chests in that game. So there's chests that are like the boss chest or things like that, and they give you loot based on the level you are when you open them. So in that game, you could leave all the chests until your last level, and then you would get a whole bunch of sweet last level loot. People were kind of exploiting that because since you could move the chests, they would just take all the boss chests back to their like home lair and then open them when they were high enough level. So they actually changed that game I think they patched it later after they solved this problem, where if you move a chest, it locks it to your current level, and it actually does the random roll then, as opposed to at the very end. So there's stuff like that you got to think about. Like, this is exploitable. It can be game breaking. I don't honestly know why they care. Maybe they didn't patch that out. Maybe it was like that. But
Well,
go ahead.
And I don't know, just a quick question on that. Like, did they, if they did patch that, did it patch it if you didn't move it? And does the boss
I don't know.
respawn and stuff? Like,
I don't know, but the making it lock to when you move it or open it means that you could still save it till the end of the game and roll high level, but you'd have to go all over the map to find all those chests again and remember where they are. But entities is another thing that is often created with random number generators. Pretty much every RPG, like the Diablos and the Grim Dawn or whatever that one is, they're random rolling the physical damages, the physical resistances on a lot of their stuff. They have a set of rules that those can be defined, and you might roll a really sweet one, you might roll something mediocre, you might roll junk. Another thing that can be randomly generated or procedurally generated is the levels themselves. So probably everybody's heard of the game genre roguelikes. That phrase came from a game that actually was released all the way back in 1980, which was called Rogue. And it looked like this. Amazing randomly generated levels and high resolution. So this was Rogue, and this is actually even a later version of it. Previous versions of it were all ASCII text. But Rogue was one of the first games that I know of that randomly generated levels. And so now games that have dungeons that are procedurally generated or randomly generated that you crawl through are often called roguelikes. Tons and tons of games have taken inspiration from the original Rogue game. Torchlight and Diablo, both of those games build levels in chunks. So they have artist-designed chunks that were hand-created by artists to be interesting and, kind of balanced or whatever. And then they know that those chunks have certain entry and exit points. And then they randomly generate, like the rift runs in Diablo, or the maps you can get in Torchlight, similar games like that. They're basically stitching together those chunks in unique configurations. Some of that can be further altered by those chunks having some randomness to themselves, like the types of enemies that spawn in them, or what the chests are, or maybe they are in various states of decay or lit differently. So they can add more randomization on top of that to make it look even more different. If you're really looking for it in Diablo, you can see like, oh, I start recognizing this area always has a set of stairs up and a set of stairs down, but it might have different bookshelves or different decor and things like that in it.
There you go, okay.
Oh,
See you,
yeah,
man.
thanks for
Thanks.
coming, man.
See you, Colby.
Hey guys, you're gonna put that on?
Yeah, I'm hoping to upload this to YouTube or somewhere.
I'll
so.
watch it then. Thank you.
Yep. Thanks for coming. Textures are another thing. I was doing some research for this talk and I can't find a single real quote unquote, meaning like released game that is not a prototype or a tech demo that actually uses procedurally generated textures completely. Games like No Man's Sky, I think, have some pre-baked textures and they alter the colors and they may put different normal maps, which simulates like bumpiness when it's rendered. And they do some randomization, but the actual texture data, I couldn't find any definitive games that were like, this uses randomized textures. Animation. Procedural animation is relatively new because it takes quite a bit of processing power and quite a bit of math that computers weren't capable of handling too long ago.
Can you change your screen? I'm like zoning out on the 5, 4, 3.
Oh, sorry. We'll go back to bright sun.
Like this reminds me of my old blacklight posters.
Yeah.
Yeah, that's cool.
Spore was one of the first games that used procedural animation that I know of. No Man's Sky uses it heavily. I don't know what other modern games use procedural animation, but procedural animation is where you take the structure of an object and figure out how it should move. So Spore was mind-blowing because when it came out, I don't know of any other game that did this. It figured out how a 3-legged or a 6-legged creature should walk, if it had a tail, if it had a long neck or a short neck, and it put together and animated those based on how they were built. Go ahead.
Although going to Spore, as cool of a game as it is, I mean, I used to play it a lot when I was a kid, but it was like, you could tell that they had preset
Yeah.
like walking patterns and things,
Yep.
regardless of whether or not the thing had 3 legs, 5 legs. What was cool was that the animation would determine, oh well, if this creature has a leg on its forehead, for instance, where would the leg have to move in order for it to do things normally?
Yeah.
And that's where you would get some weird stuff, like where you get close to a tree and your foot's on top. And,
Yeah, and that's the problem with procedural stuff is
Yeah,
figuring out.
the tree foot problem.
Yeah. So animation is another thing. Audio. The only game that I know of that uses procedural audio is No Man's Sky. So it layers different audio together. There are some games like that use beat detection and stuff. A lot of games actually will change the music to where when you get in a fight, the music ramps up. Their mixing, you could call that procedural, I guess, because it's not like a pre-baked track.
I guess sort of procedural music editing.
Yeah, and No Man's Sky actually, I think, does like some pretty sophisticated layering of music. Like it doesn't have a specific soundtrack. I think they worked with a band to get different kinds of recording, and then they're layering them in different ways. I don't actually know that much about how they did it, but
Cool.
I know they have pretty heavily procedurally rendered audio. And then, of course, all the things. You can try to do all the things procedural, and that, again, No Man's Sky is really heavy on that. Go ahead.
I think I saw a third-party package for Unity where you could procedurally generate like in bard music. And it was just like a bunch of pieces, and then it would like procedurally generate any in number of.
Well, there's a
music.
lot of individual tools too that artists use. Like there's tree generators. There's a lot of asset generators, like rock generators, things like that people use to get their meshes. And then those might end up pre-baked in the game, but the artist, and again, that's where the tool can save you time. Like you can generate 1,000 trees and just pick out the 5 first coolest ones that you see that are the most interesting.
Yeah, like I use.
and like Unity actually has a tree generation tool.
Yeah, I was gonna say, I didn't know they had it built in, but I've seen them on the asset
Yeah.
store.
And it's I'm sure the ones on the asset store are probably 10 times what the basic tool does, but what it does is it has a set of pre-built textures for trees, and it adjusts height and foliage density and creates them. And you can drag them, and I think that it even takes into factor like height of the map too. Like it's
Okay.
really cool.
Huh.
Yeah, and I use like Filter Forge for procedural texture generation.
Mm-hmm. Well, and artists use tons of Photoshop filters, or
Yeah.
they'll bring in photographs of stuff and then combine them and filter them, and so a lot of that stuff is kind of combining different techniques. So kind of the last bit I had, and then I can show you some actual demos of stuff from my game if you want to see them, but I wanted to talk a little bit about a few of the downsides of procedural stuff. So there's a trade-off that you always have to make between what I call pre-baked and runtime generated. So baking is a term that I first heard specific to like graphics, like level building and rendering. Like if you bake the lighting, you are calculating what all the lighting should look like on a texture, and you can give the computer hours to do that if you need to.
And it doesn't matter how many lights you have.
Yeah, you could have 10,000 lights, and then you just save that information into the texture. You physically change the texture to do that. Like Unreal Tournament did that way back in the day. You design your level, then you would bake the lights, and that would color all the walls and everything based on the light that was around them. That's great if the lights aren't changing in dynamic. Dynamic lights take a whole bunch more processing power, so you bake all the static lights, and then you can have more processing power for the dynamic ones and shadows and things like that. So I kind of borrow that term and use it for anything that you might generate procedurally, like these planets, but then you actually save that texture data and use it. I just call that baking it, because it means you're not doing it at runtime. You're not actually generating textures while the game is running or generating content. So there's always this trade-off. Generating information is heavy on the CPU and possibly memory, depending on what you're doing. And it's kind of unpredictable. Like you could have a noise generator that generates black and white clouds that just happens to generate one that's all black. Super rare, might be like flipping a coin and getting heads 150 times in a row, but it could happen. And that's kind of the problem with purely random stuff, is you don't know what you're gonna get, and purely random is rarely pleasing to the eye. And so there's kind of a trade-off where if you go too far random, you just get chaos. If you go too far towards hand created, it's very time consuming, or
I think
You don't
everybody
have
knows
a
how
lot of
repetitive the Diablo levels feel after a while,
Yeah.
right? I mean,
yeah, or after you've been in the 7,000th house in Skyrim and they all have the same set of shelves with the
Yeah.
same set of books in slightly different orders and the same set of plates. I mean, those are the trade-offs, right? Like the artist can only churn out so many assets. It's pretty tough to procedurally generate unique and interesting flatware for your table. Like, people don't spend time on that, so they compromise.
Well, although, funny note on that, there are like 15 different forks in Skyrim.
Oh, really?
Like,
I'm not
legitimately,
surprised.
They made like 15 different versions of all of that flatware and stuff.
I'm gonna
That's
play
fine.
through again and collect all the forks.
Another downside is, and to me this is a big deal, you can't math your way to interesting and fun. I have played so many roguelikes that advertise, procedural levels and like basically promising kind of unlimited content. But you get into it and you're like, well, yeah, the levels are technically unlimited, but like there's only 7 different sprites and there's there's only 3 enemies. That kind of fake content or recycling of a limited content set is not going to be interesting and fun. So the best use of procedural is a nice balance between, it's not a substitute for an artist. It's not a substitute for good art. And then the last big one that I've run into is balance issues. Random is random. So there's a chance you're gonna roll a game-breaking gun that can just kill everything in one shot. Or the opposite, you're at a really high tier and you beat a super great boss and you get a butter knife or whatever. So that's a problem, but it also causes other problems. Like in my game, I'm generating sectors and I'm generating suns, and I'm probably on the 5th iteration of the math to keep suns from overlapping each other unrealistically. Like, it is such a harder problem to solve than I would have guessed. And I'm doing it pretty brute force now. I'm checking every time I'm gonna create a certain number of suns when I'm generating this world. So I create one and then I check it against all the other ones. And if it overlaps or it's too close, then I get another random position and I check that again, and I just recursively brute force until I have an interesting position. I think it's kind of similar to like the knapsack problem if you're big into math. Like, it is hard to find a place where something fits through an equation. It's easier to just brute force it. And my level gen, I'll show it to you guys in a little bit. It's so fast that I have some time to waste on stuff like that. I can create a whole new world for my game, a whole new save file in a fraction of a second. So it's pretty quick. But balance issues, balance both in terms of gameplay, but also visually, getting stuff that doesn't kind of break the immersion of the game. Like when I have a planet and, it looks like it's on the surface of the sun, and it's like it just doesn't look right. And it's hard to create a good enough set of rules to keep that from happening, but still let the game be natural. And if you played Minecraft for a really long time, you saw the evolution of that. Early Minecraft maps were not fantastic, and it's gotten steadily better. So that's kind of the main content. We talked a little bit about kind of where it started, the history of it, different ways it can be used. Some kind of visual examples of how you can use noise and color and distortion of a texture to get something unique without drawing a single brush stroke. Do you guys have questions? And then after this, I'll probably kill the video recording and just show you guys kind of how I'm doing some stuff. If you want to. Yep.
You talked about the balance between purely human created content and purely random content. And it seems like you're saying the best way to provide balance and guard against the pure randomness providing imbalance in the game is to provide a human eye. But what if you provided constrained rules from your generator that would say, okay, do we have any really super long hallways, or are the suns overlapping? Is the overall all aggregated power level of this gun too high or low? Stuff like that could be another way to balance out the randomness of
and you try to do that. So
you just have to think of all the rules.
And that's the problem.
Yeah.
Like thinking of every combination that could be exploitable or break is super difficult. So for example, with Masteroid specifically, my game, I came up with a sort of power index of a ship. But that wasn't good enough because just one number, maybe the ship is really good at mining, maybe it has good speed and good cargo space, but its weapon is garbage. Well, that's not necessarily undesirable.
Makes sense, but the other factors were so far out of whack potentially.
Right, and so then I ended up having an index for its mining quality and its fighting quality and its exploration quality.
So already you've got all this complication with trying to
Yep, and everything you randomize adds like an exponential layer of complication. So like with my sector generator, that's the biggest thing I've been working on for a while. Really the only way is generate a world, play it for a little bit, or like try to experience as much content as your generator can spit out, and then find the things that don't look right. Like I thought I had the suns problem solved like 6 different times, and then I got the one dice roll that gives me 6 suns all layered on each other, and I'm like, how'd this even happen? Oh, well, if the sun is close to the player's plane and is above this scale, and another one generates also above this scale, but is, in this place, then they overlap visually, even if they don't mathematically, because I'm looking at it from this angle.
Right.
Like they're overlapping now. They're not if the camera's like this, but if they generate in these two proximities at these scales and the player moves this way, now the suns look weird. I can tell that they're flat. They lose the illusion because my game uses tons of this fake 3D. It's all flat sprites, but it uses depth in Z-index and flat sprites to fake 3D, and it looks really great until it doesn't, and then it completely destroys the
You
illusion.
could get to a point where you're like, screw it, I'm just gonna have 6 sun location configurations and I'll pick one of those and then.
That was my iteration too. I literally did that. I divided the sector into 9 grid spaces, and I said only one sun can exist in each of the grid spaces, but I do allow them to be very far back or very. Still was broken because you could still generate a sun in the bottom right corner of this grid and the top left corner of this grid, and at this angle they're overlapping and it's all screwed up. So yeah, that was like iteration number 2.
Well, that would work if you set it so that you added like a radius to it. Like it couldn't generate within a certain space of that, or
And
there had
that
to
is
be
actually the
complete-
current iteration. That's what I did.
Nice.
Okay.
Yeah, so I actually positioned them in 3D, and even though they're 2D sprites, I look at their 2D dimension and I project that to 3D, and I don't let them be closer to each other than that. So I am pretending
Or
like
just
they're
make your
3D.
9 possible volumes where suns can exist, like separated from each other.
That gets
Buffers.
really annoying mathematically
Okay.
to like figure all that out, and like I did all that and I was like, why don't I just pretend like they're 3D and collide them against each other and move them? And that's the current
Sweet.
iteration.
That's
I'm still
awesome.
testing
I
that,
like
but yeah, I've been through multiple iterations. I'm gonna go ahead and stop this recording now just because it's probably a huge amount of space, and